today we are going to be solving section 2.2, solving inequalities using addition and subtraction. So let me unfreeze this so everyone can see. This is the page I would like you to open up in your packet. Yesterday we worked on graphing inequalities. Today we're going to start solving them. So solving inequalities is just like solving equations. So you're basically going to be taking away addition and subtraction first, and then multiplication or division second. The only thing that's different with inequalities is your answer will have a graph attached to it because every inequality has infinite solutions. So your graphs are going to be necessary and important for each answer. And instead of having like x equals 5 as your answer, it might be like x is less than 5. So the process is still the same. We just have to deal with these symbols and now including a graph as well. So when we're solving inequalities, I'm just going to rewrite this. X minus 6 is greater than or equal to negative 10. If it's helpful for you to circle the variable you're solving for, please still do that. This is still the same process. If we have x minus 6, we want to get rid of that minus 6, and we do the opposite of that. What's the opposite of subtracting 6? Chase?
Plus 6.
Yes, so we're going to add 6 to both sides. Same type of work I will be expecting for inequalities as I did for equations. On the left-hand side, I'm left with x. The symbol stays the same. It's going to be a greater than or equal to symbol instead of just an equal to sign. And then on the right-hand side, you would add negative 10 plus 6, and that's negative 4. This is your answer in inequality form. X is greater than or equal to negative 4. Now it's time to graph our answer. So the only number that I need you guys to put on your graph is the endpoint. The endpoint is this number right here. So you would include negative 4 on your graph. I usually just put it right in the middle. And then you decide what type of circle it will be and where the solutions are, whether it's to the left of the number or to the right of the number. So, starting with the circle, what type of circle would I have around the negative 4? Eli?
Closed circle?
Yes, it would be a closed circle because negative 4 is a solution. Negative 4 is a solution because of the equal to sign. You guys right?
Yeah.
Okay. So, closed circle here, and then where are the solutions? To the left of it or to the right of it? Chase?
Right.
Yes. Anything that's greater than it would be to the right. So, here's what the graph would look like. A closed circle at negative 4, answers pointing towards the right. All right, the next one. You writing this down? You're going to need to. The next one. Y plus 8 is less than or equal to 5. We're solving here for a y. We need to get rid of this 8. What would I do to both sides to get rid of that 8?
Subtract.
Yes. So it's currently adding, so we would subtract 8 from both sides. When I do that, those 8s cancel out. And I'm left with y is less than or equal to, the sign stays the same, 5 minus 8 is negative 3. So that's your answer in inequality form. Now it's time to graph. The only number I'm requiring you to put in the graph is the endpoint. If you want to put more than one number, that's fine. If you want to put negative 2 here and negative 4 here, that's fine. You don't need to. You only need this number. Next thing you do is decide the type of circle, which this will be the same exact circle because it is also a solution of the inequality. Anytime you have this little equal to line underneath, it means it's going to be a closed circle because the equal to part makes it a solution. Where are all the numbers that are less than or equal to negative 3? It will be to the left of the negative 3 or to the right? Maya?
To the left.
Yes. Okay, great. Does anyone have any questions on that so far? All right. Moving on to the next two, getting a little bit more difficult. So the next thing we're going to do is solve this one for M. So the way that it is set up, we have negative 8 is less than 1.4 plus M. Just rewriting it. Circling the variable, which is on the right-hand side, we need to get rid of that 1.4. That's a positive 1.4. To move that to the other side, we would have to get rid of it by subtracting 1.4. At this point in the game, you guys should be able to use calculators. The easiest calculator for you to use, even though it's hard to start using in the beginning is a graphing calculator, because once we get into the more difficult stuff, it'll basically do the math for you, which is really helpful. But if you don't have this, then hopefully you have just a different calculator you can use. On the Keystone, when we come time to that, if we do take it this year, they will not be letting you use your phones for a calculator, so you're going to need one eventually. You might not need this, so you might be able to do this in your head. -8 minus 1.4 is -9.4, and this is going to be less than m. Now, my brain does not work this way. I struggle with graphing these. I know that I can put -9.4 on the graph because I only need the endpoint on there. I also can tell that it's an open circle. I know that it's an open circle because it's just a less than symbol. But usually, the less than symbol means the answers are going to be to the left. That only works if the variable comes first. Because this says -9.4 is less than all of the answers. If -9.4 is less than all of the answers, that means all of the answers are bigger than -9.4, which is confusing. I prefer to have these things in the opposite order. I prefer to have the m first and the -9.4 second. When you do that, you can't just rewrite the symbol the same way because that's not going to be correct. Notice, the symbol is opening towards the m, so when I flip it around, it's going to turn from a less than symbol to what symbol? Greater than. This is the way that I prefer to graph. The answers are actually to the right of -9.4, not to the left of -9.4. So it's really important to decide, can you graph this way? Do you understand what this says? If not, please take the extra 10 seconds, not even, maybe like 3 seconds, to flip the numbers and flip the sign so it's easier for you to determine which way the solutions go. And then the last one on this page, I believe, is s minus -1 is greater than or equal to 2. When I have minus a negative, it really turns into a positive. So this is really saying s plus 1 is greater than or equal to 2. Minus a negative really means plus. So the only thing I'd have to do here to solve this is undo plus 1 by subtracting 1. And I'm going to get s is greater than or equal to 1 as my answer. How would I graph this? What would I do to graph this inequality? Chase?
You put the 1 in the middle, and then full circle, and then point it to the right.
Perfect. Thank you so much. Great. Did I say I was going to give you packet today? No. Did you lose it? I think I did. Thank you. Do you need a packet?
No, I don't know.
You never got one? All right. So on the next page, there's 1, 2, 3, 4 practice problems. These are definitely going to get a little bit more difficult as you go through. So what I want you guys to do is please try them. There's some fractions here. There's some negative numbers here. And then this one, there's some combining like terms in number 4. You can use a calculator. You can work together. I'm going to give you guys maybe like 6 minutes or so to solve and graph all of these. Then we'll go over them as a group. You'll have to write it down. And if you guys don't know the that's fine. So you'll have to write it down. And you can see them up here too. These are the facts you look at.
Great question. Kind of wondering. I think it's
All right, we're going to go over these. If you're not finished just yet, you can go through with us and copy these answers down. As we go over problems, it's really important to fix any mistakes that you make so that your notes are accurate. So when you go to study, your answers and your questions and notes are all correct. So we're solving this first inequality for k. What will I do to both sides to get k by itself? Alex?
Subtract 5.
Perfect. We're going to subtract 5 from both sides. We're going to get k is less than or equal to -3 minus 5 more is -8. This is your answer in inequality form. On the graph, we would put -8 here. This will be a closed circle. Anything that's less than it will be to the left, so that would be your graph. Number 2 is fractions, but don't freak out. It's the same exact process you would normally do. It's just now you're dealing with fractions. I'm going to rewrite it so it's a little bit bigger. 5/6 is less than or equal to z plus 1/6. I'm solving for z. How will I get rid of plus 1/6? Chase?
Subtract 5/6 or 1/6.
Yes, subtract the 1/6 to move this, yeah? So I'm going to subtract 1/6, and thankfully this works out nicely since 5/6 minus 1/6 is just 4/6. Now, technically, we can simplify that. 4/6, you can divide 4 by 2 and 6 by 2. This technically simplifies to be 2/3. And this is another one that I don't prefer to graph this way. I like to have the variable and numbers flipped. On the number line, I can still put 2/3 or 4/6. It equals the same thing, but this is simplifying. But when I go to graph it, I like to flip these, and when I do flip that, I have to flip the sign as well. That means that the solutions are anything bigger than or equal to that number. That means it would be a closed circle, and the answers are actually to the right, not to the left. Number 3. This is a weird one because we are solving this for h. And right now, this is being added. And usually when there's addition, to undo addition, you would subtract. But the number we're trying to get rid of is this number here. So you have two options. You can either think of it, guys, I'm trying to record this for other kids. You can think of this either you can either subtract negatives, and if you subtract a negative, then it actually just adds it. Or you can think of it just as trying to get rid of this -3 by doing the opposite. The only number that will cancel with a -3 to make it 0 is what number? It's the only number that will cancel with a -3 to turn it into 0. What's the opposite of -3? Yeah, +3 plus 3. So even though this is a plus sign here, we actually need to get rid of this -3. If I was to subtract 3 from both sides, it wouldn't cancel out. The only way to cancel out this -3 or -3 is by adding 3. So this is an interesting one. -3 plus 3 is 0. I'm left with h is greater than. -3 plus 3 is another 0. So this one has an endpoint of 0, which is still fine. Anything that's greater than 0, so above the number 0, we would have an open circle. Anything greater than that would be to the right. And then the last one, number 4, is going to require us to do some simplifying before we can start solving. So in number 4, we have some like terms here. I have 12 is less than or equal to 4c minus 3c. We should combine these together before we do anything. 12 is less than or equal to 4c minus 3c is how many c's? 1c. So this simplifies to just be 1c plus 10. You can put the 1 in front of the c, or you can just leave it just c. Now I'm solving for this, now that I only have one of them, and to do that I would get rid of this plus 10 by minusing 10. 12 minus 10 is 2. I get 2 is less than or equal to c. I don't like to graph this way. I want to flip everything, so I'm going to flip the c, flip the 2, and then I have to flip the sign as well. This is what I'm going to graph. C is greater than or equal to 2. So then on my graph, I would have 2. I'd have a closed circle at 2, and anything greater than or equal to it would be to the right. So all of those problems were skill-based problems. Now let's try some word problems. If you look at the other side, modeling with mathematics, we're going to start the first word problem with this section. So number 6 says, a circuit overloads at 1,800 watts of electricity. You plug a microwave oven that uses 1,100 watts of electricity into a circuit. Write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. Okay. So the maximum amount of electricity you can use is 1,800. I know that. So the maximum is that amount. So I know that all of these appliances that you're plugging in have to be what compared to 1,800? What symbol? Less than or?
Or equal to.
Or equal to. So I I know that the maximum is 1,800. So everything that you plug in must be less than or equal to 1,800. We already have 1,100 watts of electricity being used by the microwave. So anything else that we plug into here can't exceed the sum of 1,800. So the inequality that I created is 1,100 plus x, with x representing all the other watts of electricity from the other appliances, must be less than or equal to 1,800. So it just says to write and then solve it. So to figure out how much electricity we can use, we would solve for x by subtracting 1,100 from both sides. And what will we get as our answer? Perfect. So this problem doesn't say to graph, it just says write and solve. So this means that you can use up to 700 watts of electricity for your other appliances. It's asking which of the following appliances could you plug into the circuit in addition to the microwave. So could you plug in the microwave and this radio that has 50 watts?
Yes.
Yes.
Yeah, sure.
And each one's separate. Can you plug in the microwave and the blender?
Yeah.
Yes. Could you plug in the microwave and the toaster oven?
No.
No, because that exceeds the limit. Number 7 is almost identical. It's the same amount of watts of electricity. It's honestly silly to do it again. We're going to skip it and complete the back side here. So let's skip this and flip over to the other side. Number 8 says you have $15 to spend on groceries. You have $12.25 worth of groceries already in your cart. Write an inequality that represents how much more money, M, you can spend on your groceries. So you have at most $15. When you go out and you're buying anything, if you have $15 in your pocket, you know you can spend up to that, but you can't exceed it. What inequality symbol would represent that? Jason?
Greater than, less than.
Well, greater than or less than is two
I'm
opposites.
sorry, greater than or equal to.
So if you have up to $15, that would mean you could pay $16.
Oh,
Flip it.
okay.
Less than or equal to.
Less than.
Perfect. So less than or equal to $15. We already have $12.25 worth of food in our cart. We want to see how, they want us to use M. We want to see how much more we can buy with the amount of money that we have. So here's the inequality I could create. 12.25 plus M must be less than or equal to 15. And a lot of you are probably solving these without creating the inequalities first. And I understand. Sometimes it's hard to create them first. To solve this, we would subtract 12.25 from both sides. And what will we get as our answer?
3.25.
13.
Yep. 2.75. Sorry, Chase. Just gotta work on your mental math. Or was it you, Alex?
It was him.
All right, what I want you guys to do is try number 9 on your own, and then we'll go over the answers together.